Hey everybody, welcome to Studio 64. My name's David. I've been searching the interzones for more science, space and tech news to share with you. Came across this at the conversation. This should be interesting. Witness 1.8 billion years of tectonic plates dance across the Earth's surface in a new animation. Okay, very interesting. Now, using information from inside the rocks on Earth's surface, we have reconstructed the plate tectonics of the planet over the last 1.8 billion years. It is the first time Earth's geological record has been used like this, looking so far back in time. This has enabled us to make an attempt at mapping the planet over the last 40% of its history, which you can see in the animation below. The work led by Xianzi Chao, I believe that's how it's pronounced. I do apologise if we've got it wrong, from the Ocean University in China, is now published in the open access journal Geoscience Frontiers. Now, as usual, I'll leave the link to the main article below the video, so you can pop in, check out the embedded links, go for a bit of a deeper dive if you want. Makes for an interesting read, believe me. Let's check out this little animation. This should be cool. 1.8 billion years of tectonics. That's cool, isn't it? Look at those continents move. Holy crap. That is cool. There you go. Wow. If there are any planetary scientists out there, I say I'm not a scientist myself, I just love all science, space and tech news and love sharing it. But if there's any planetary scientists out there, please feel free to comment below the video because I'd love to hear from you. It'd be fantastic. Thank you. That's absolutely amazing. And there they go. Huh. That is very, very clever. That was really cool. I really liked that. That was awesome. Yes, a beautiful dance. Now, mapping our planet through its long history creates a beautiful continental dance, mesmerizing in itself and a work of natural art. It starts with a map of the world, familiar to everybody, and then India rapidly moves south, followed by parts of Southeast Asia, as the past continent of Gondwana forms in the southern hemisphere. Around 200 million years ago, Ma or Mega Atom in the reconstruction, when the dinosaurs walked the earth. Now, Gondwana linked with North America, Europe and Northern Asia to form a large supercontinent called Pangaea. Then the reconstruction carries on back through time. Pangaea and Gondwana were themselves formed from older plate collisions. As time rolls back, an earlier supercontinent called Rodinia appears. It doesn't stop here. Rodinia in turn is formed by the breakup of an even older supercontinent called Nuna, about 1.35 billion years ago. That's incredible. That's really cool. Why map Earth's past? Among the planets of the solar system, Earth is unique for having plate tectonics. Oh, that's something I wouldn't realise. Its rocky surface is split into fragments or plates that grind into each other and create mountains or split away and form chasms that are then filled with oceans. Apart from causing earthquakes and volcanoes, plate tectonics also pushes up rocks from the deep earth into the heights of mountain ranges. This way, elements which were far underground can erode from the rocks and end up washing into rivers and oceans. From there, living things can make use of these elements. Among these essential elements is phosphorus, which forms the framework of DNA molecules, and molybdenum, which is used by organisms to strip nitrogen out of the atmosphere and make proteins and amino acids, the building blocks of life. Plate tectonics also exposes rocks that react with carbon dioxide in the atmosphere. Rocks locking up carbon dioxide is the main control on Earth's climate over long time scales, much, much longer than tumultuous climate change we're allegedly responsible for today. Yes, Iceland is on a plate boundary, which makes for frequent activity. Cool. That's awesome. Nice pick. Love to see something like that. But not for too long, though, just in case it decided to be in a bad mood. The volcano's in a bad mood today. Yes. A tool for understanding deep time. Now, mapping the past plate tectonics of the planet is the first stage to being able to build a complete digital model of Earth through history. Such a model will allow us to test hypotheses about Earth's past, for example, why Earth's climate has gone through extreme snowball Earth fluctuations, or why oxygen built up in the atmosphere when it did. Indeed, it will allow us to much better understand the feedback between the deep planet and the surface systems of Earth that support life as we know it. Yes, we're aware that Antarctica used to be tropical at one point. So climate change has always been around, but I have a tendency to the hysteria about it's just unbelievable. People are freaking out over it, and I'm going, when I was growing up, it was global freezing. We were heading towards a new ice age. Then it was the ozone layer. Then it was global warming. You know, the ozone layer, we're all going to be fried to death unless we had 4 billion sunblock. Then it was global freezing. Then it was global warming, and by the year 2000, we'd all be 25 million metres underwater. That never happened. And now it's climate change. If it rains too much, it's climate change. If it doesn't rain enough, it's climate change. Dear God, it's bloody ridiculous. If it doesn't rain, it's climate change. If it does rain, it's climate change. Jeez, bloody hell. But you notice that they don't bang on about China and India. You know, especially, look at China. 300 million more tons of coal in 2022 alone, so they can, keep those electric power plants running, so you can build more electric cars, so everybody in the West can be morally superior driving around, saving the environment. Fascinating. So much more to learn. Yes, modelling our planet's past is essential if we are to understand how nutrients became available to power evolution. The first evidence for complex cells with nuclei, like all animal and plant cells, dates to 1.65 billion years ago. This is near the start of this reconstruction and close to the time the supercontinent Nuna formed. We aim to test whether the mountains that grew at the time of Nuna formation may have provided the elements to power complex cell evolution. Now, much of Earth's life photosynthesis and most of Earth's life photosynthesizes, I should say, liberates oxygen. This links plate tectonics with the chemistry of the atmosphere, and some of that oxygen dissolves into the oceans. In turn, a number of critical metals, like copper and cobalt, are more soluble in oxygen-rich water in certain conditions. These metals are then precipitated out of the solution. In short, they form ore deposits. That's really, really interesting, isn't it? Again, I'm not a scientist. I just love all this sort of stuff. It just makes me think, we're the only planet we know so far that has tectonic plates. There's got to be others out there. Now, many metals form in the roots of volcanoes that occur along plate margins. By reconstructing where ancient plate boundaries lay through time, we can better understand the tectonic geography of the world and assist mineral explorers in finding ancient metal-rich rocks now buried under much younger mountains. Really? Interesting. Thought we were not supposed to be doing all that sort of thing anymore. Unless it's, destroying the planet in order to get rare earth metals to save the planet with electric cars. In this time of exploration of other worlds in the solar system and beyond, it is worth remembering that there's much about our own planet that we're only just beginning to get a glimpse of. There are 4.6 billion years of it to investigate, and the rocks we walk over contain the evidence for how Earth has changed over time. Now, this first attempt at mapping the last 1.8 billion years of Earth's history is a leap forward in the scientific grand challenge to map our world, but it's just that, a first attempt. The next years will see considerable improvement from the starting point we have now made. That is Misha Ketchel. Well done, Misha, I believe. Very, very good indeed. Yeah, that was excellent, wasn't it? Yeah, 1.8 billion years of tectonic plates dance across the Earth's surface in a new animation. Yeah, I think that's pretty cool. As I say, love little things like this. making these videos so I can understand more and share this with people so we can all understand more. And as I say, there'll be more science videos coming up in space and tech videos, because the more we understand, the more information we have, the better off we are. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. Greatly appreciated. And if you're up for it, drop a comment down below the video, because I'd love to hear what you think. All right, take care. And as I always say, if you can't be good at it. And as I also always say,
my brain hurts. 5, 4,